some force to stop. If you do not apply any force, the object will keep on moving. So second example we will see, inertia of rest example, inertia of motion example, inertia of motion. If brake fails in a car, car keeps on moving despite engine is switched off. It keeps on moving despite engine is switched off. Similarly, this is one example. We can have many other examples. If something is moving in a direction, aeroplane, we can have aeroplane. Gliding in air, or the kite or glider, which are not experiencing any force. They are just gliding in the air because of its initial velocity. So kite or glider moving with constant moving velocity without applying any force, without applying any external force, without getting any external force. Okay, so these are the example of inertia of motion. Similarly, inertia of direction we have already discussed. So that is cricket ball. Inertia of change of direction. Change of direction of cricket ball. Okay, so we have already discussed this thing. So we will move further. Now we will discuss the second law of motion. Second law of motion discussion. So what is this second law and first law of motion represent? So second law is F equal to ma. Second law is what? F equal to ma. But first law is what? If F equal to 0, then A equal to 0. So can we say that first law is a special case of second law? Because in this expression, the second law expression, if you put F equal to 0, automatically we get A equal to 0. So can we say that first law is special case of second law? But we do not say like this. Why? Because first law is given before the second law. And if the first law is applicable, if the first law is true in some frame, then only second law comes in picture. Although it seems from the equation form, it seems that first law is special case of second law, but the second law comes into picture only when the first law is already given. What I'm trying to say is the second law is not true in all the frames. There are many frames, there are many places where second law is not applicable. So first we will see that whatever Newton gave the first law is applicable there or not. If first law is applicable, only then second law comes. So we cannot say the first law is a special case of second law, but we can say that first law is base law, then second law is its advanced form. First law is the base law and second law is its advanced form. I can give you example of some places where the first law is not applicable. For example, those things we will study in pseudo force. So I am giving an example. Suppose we have a bus, and inside the bus, suppose an object is kept. An observation is taken from inside the bus. If this bus accelerates, this object will tend to move in backward direction, because, and if there is no friction, if the surface is smooth, the lower surface is smooth, the object kept on the ground will tend to move in backward direction. So for the person here, the person who is inside the bus, what he will see? he will see that the object is moving in backward direction without applying any force. So if the bus accelerates, suppose the bus accelerates with some acceleration, then the person will see that this object which is kept out of smooth surface inside the bus, the object is tending to accelerate in backward direction inside the bus. So this acceleration of this object is what? Non-zero. But the force in horizontal direction on the object is zero. So this is the direct, you can see, this is the first law is not applicable inside this frame. So if first law is not applicable, the second law can also be not applied on inside this bus. So the first law is what? The first law is for defining the inertial frame. Inertial frame means the frame where we can apply the first law. So what we will say here, what we will discuss here is, what we will say here is a frame in which first law is applied, a frame in which first law is applicable. Applicable is called inertial frame. Is called inertial frame. So inertial frame. What is inertial frame definition? What is inertial frame? So inertial frame definition you must know. This is inertial frame. A frame in which first law is applicable is called inertial frame. And what are the inertial frame? Actually, any frame which is not accelerated is inertial frame. You can see this bus is accelerated. That's why we are not having the first law of motion applicable here. So any frame which is not accelerated. So inertial frame is basically what? Not acceleration with no frame, or a frame having no acceleration. So a frame having no acceleration is called inertial frame. A frame having no acceleration. A frame having no acceleration is called inertial frame, and in this frame only we will have the law of inertia applicable. No acceleration with respect to what? With respect to ground we will see. With respect to ground. With respect to the frame having no acceleration with respect to ground is called inertial frame. And in that frame only we will have law of inertia applicable. And if law of inertia applicable, only then we apply the second law. And then we say if a frame is inertial, if a frame is inertial, only then second law is applied. Okay, so these things are there due to for second law. On since the forces and acceleration are in vector form, we can write separately for three directions. We can write like this: fx equal to 0, then f equal to, we can write like this, ax equal to fx by m, we can write like this, ay equal to fy by m, and similarly az equal to fz by m. Because these two quantity are vector quantity, acceleration and force both are vector, so we can write the forces along three directions separately, and we can write the equations like this. So we will see when we will solving the problem, we will see how these things are done actually.